Dear students, in this chapter water, we discussed physical properties of water already. Today, we will discuss one more physical property of water which is very unique for water and therefore it is very important, and that is being extremely good solvent. So good solvent that it can dissolve almost each and every substance, each and every solid, liquid and gas sooner or later in smaller proportion or in bigger proportion. It is such an extremely good solvent that even the container in which it is kept, even if it is an insoluble substance like glass, then also a very small amount of it can dissolve in water. If you drink distilled water, then the minerals and the nutrient present in your intestinal stomach can dissolve in the water. Therefore, you people are advised not to drink distilled water, but the water containing already minerals, gases and other things dissolve into it, because being very good solvent, rather than providing us some nutrient, it can even take nutrients from our body. So, to understand it more, let's discuss solutions. What are solutions? A homogeneous mixture of two or more substances in which the component means proportion of the different components, two or more components may vary. So, if suppose we think a solution, a true solution means homogeneous solution, then out of two components, one can be called to be solute and other to be solvent. And solute is the one which is in comparatively smaller proportion, and solvent is the one which is in comparatively larger proportion. But here in this chapter, we are talking about water as solvent. So, though each and every substance will dissolve in water mostly in smaller or more proportion, but those substances which mix well in water to form a true solution, they only are said to be solute. For example, if we talk about liquids, alcohol, fruit juices, milk and acetic acid, etc., they can dissolve very well in water to form a true solution. So they are said to be the liquid which dissolve in water, and they are said to be miscible liquids. Whereas certain liquids which do not mix well to form a true solution, they are said to be immiscible liquids, like kerosene oil or petrol or diesel. These are the liquids which do not dissolve in water to form a homogeneous solution. Therefore, they are not said to be solute for water, and therefore such liquids are said to be immiscible liquids for the solvent water. Gases as well dissolve well in water, like oxygen, ammonia, carbon dioxide, nitrogen. These gases are more or less soluble in water. Ammonia and carbon dioxide are fairly soluble in water. Actually, ammonia is the most soluble if we talk about oxygen, nitrogen, carbon dioxide and ammonia. Ammonia is the most soluble out of these four gases which are soluble in water. So, now children, certain substances are more soluble in water and certain other substances are less soluble in water. So this property is said to be solubility. If a substance is more soluble in water, in the same amount of water, suppose we take 1 liter of water, then if a substance, suppose a solid substance dissolves 10 gram in 1 liter, then and other dissolves 20 gram in 1 liter, it means the 21 gram is more soluble, or we can say its solubility is double in comparison to the one which dissolves half in that much amount. But is it only about the amount of water? No, there are two other factors which can play an important role in solubility of a solute in water. And I said solute is a substance which dissolves well to form a true means homogeneous solution. So the two means components which can play a role in solubility of solute in water are, one is not component, actually the term should be property. Two properties which can play an important role in solubility of a solute in water are temperature and second one is pressure. So how temperature plays a role in solubility of a solute in the solvent. Children, solid solutes dissolves more at higher temperature mostly and less at lower temperature. Take example of sugar. Sugar is soluble in water. As suppose you take 1 glass of water and try how much sugar you can dissolve into it. And then you heat the water and then you will see that many times more sugar can be dissolved in hot water. If water is boiling, then even more. This is because that solubility of a solute in a solvent, that is water, increases with increase in temperature and decreases with decrease in temperature. It means at low temperature less solid solute dissolves. But that is only for solid solutes. Gaseous solutes, for them effect of temperature on solubility of gaseous solutes is different. Gases dissolve more at lower temperature in water in comparison to at higher temperature. And if the temperature is too high, then gases won't stay in soluble form in water. It means if we boil the water, then all the dissolved gases present in water will leave it out, will not be able to stay in the water in soluble form. And now you can understand why Coke and other fizzy drink bottles are stored at low temperature. So that when you open the cap of the bottle, then the more of the gas can stay still in the soluble form. Otherwise, if it is hot, then most of the gas dissolved in water will move out, because now it will not be able to stay in water at higher temperature. Children and fish or other animals sometimes die in summer due to less solubility of gases in hot water. In our country, in ponds and lake, etc., if the temperature is too high, then fish and other aquatic animals start dying. This happens because the solubility of gases and therefore oxygen in the hot water is less, and due to lack of oxygen in water, animals cannot get enough oxygen to survive. So you can understand that effect on solid solute is that more the temperature, more the solubility, less the temperature, less the solubility. But effect on gases is just opposite. More the temperature, less is the solubility of gases, and less the temperature, more the solubility of gases. But though there are certain exceptions, children, if dissolution of a substance in water is an exothermic reaction, in that case, solubility of that solid solute in the water solvent will not increase. Take example of quicklime, CuO. CuO dissolves in water. So if we dissolve it in hot water, then it will dissolve less, because its dissolution, it's not CuO, CaO, calcium oxide or quicklime. Quicklime dissolves in water and lots of heat is produced. The dissolution is an exothermic reaction, so it will dissolve less. But normally for solids, the solubility, that's why I'm saying most of the solid dissolve more at higher temperature. Though dissolution of a substance in water is a physical change, not a chemical change. But if it is a chemical change, then it could be an exothermic reaction as well. Like quicklime, when it dissolves in water, actually it does not form just solution. It combines with water to form slaked lime, CaOH whole twice. So as it is a chemical reaction happening over here, that's why it gives away heat, and that's why it dissolves less at higher temperature. It means if water is hot. Then there is one more property that affects solubility of a solute in water, and that is pressure. But pressure has effect on solubility of only gases. If we apply more pressure on water, then solubility of solid and liquid solutes won't get affected. But if it is a gas, then more gas dissolves at higher pressure. Again, I'll give you example of Coke bottle. In Coke bottle, the carbon dioxide dissolved in the Coke or the soda water bottle as well. The carbon dioxide is dissolved in water at higher pressure. So lots of carbon dioxide is present over there. But when you open the cap or lid of the bottle, then lots of carbon dioxide in the form of effervescence, means the gas bubbles along with water comes out, because due to when you open the lid, the higher air pressure is released, and at less air pressure, less carbon dioxide will stay in water. So the extra carbon dioxide that were dissolved at higher pressure now comes out. Now if the water is cold, then still some carbon dioxide, a little more carbon dioxide will stay in water. But if it is hot as well, then most of the carbon dioxide that were dissolved under high pressure will come out and won't stay over there. So the conclusion is that effect of pressure on solubility of gaseous substances in water is like this, that at higher pressure more gaseous solute dissolves, and at less pressure comparatively less will dissolve. Only this much in this video.